Hi there. Pardon me. Hi there. My name is Robert, and I thank you for being here. Behind me is a building that I'd like to talk about. First, I'll tell you about myself. I've been involved in structural and mechanical engineering the majority of my adult life, and the project behind me, which I want you to keep in mind before you go to somebody else's video on small houses or whatever. This snaps together. It's a very simple building. We'll get into that later. But first, let me be clear that I'm not here to sell parts or plans or tell people precisely how to build this building. I'm going to show you the systems that I've put together that keep this as a very simple building. Now, the main mission of doing this project took about 2 years and was to design and test parts that would be off the shelf that two people with minimal skills could transport and assemble. That meant that no one part of this building two people couldn't lift and like I said, transport and assemble the building. And the most important part, that it would be under 10, at least not to exceed $10,000, which I think is a very reasonable price for a structure like this. The building is also 80% recyclable. Now we're going to go into all the details about all this. I think you'll find it pretty fascinating, and so we'll be right back. Behind me again is this the building, this prototype building. It has sustained 60-mile-an-hour winds and heavy rains, no leaks, no shuttering, it's no damage whatsoever. Let me describe the building a little bit. The total square footage of the floors is 250 square feet. The height of the building is 18 feet, 14 feet deep, 12 foot wide. The first story is 9 feet inside, so we're talking about interior heights, 9 feet for the first floor, 8 feet in the second floor. The roofing and the siding are of the same material. It's corrugated steel. The windows are vinyl thermopane, and they open up. The front door is glass. The two doors open up. They're glass. They're called storm doors. The main part that I'd like to share with you is the main structural component of the building utilizes pallet racks that snap together. They're steel components that snap together. You may have seen them at Costco or Home Depot. They're these big steel shelving systems that hold thousands of pounds of goods. These pallet racks are a global product, and they're used to warehouse goods throughout the world. You can sometimes even get them when these warehouses go out of business. They practically scrap them pennies on the dollar. You can pick those up and repaint them, and they're just as good as new. These are new on this one. Also, some of these pallet racks are seismically rated, which was kind of interesting. Now, going back to the way I use these, again in Costco or Home Depot, you may have seen they're lined up. They kind of in sections, multiple 5, 6, 7 sections. And I took those sections and turned them sideways and bolted them side by side. That structurally worked out perfectly in this test. Each of these pallet rack units, so there's 4 of them. Think of them as having 4 legs, and there's 4 units. At the base of each one of the legs, they have these pads, these metal pads that are welded to each leg, and they have holes in them for bolting to whatever substrate you want to use to secure the building to a foundation. In this case, I used 8x8 pressure-treated beams that ran parallel to each other, just 2 of them, and then bolted them to those, and then connected the next section. They were bolted together. Now, what you're looking at is a 2-story building. The same system could have been used to make a 1-story building, make it much longer. So there's all types of possibilities using these pallet racks. I think that covers this section right here, and then we're going to talk about other things. But keep in mind, this is a $10,000 building, and in parts, that's pretty good. You have your pallet rack, your frame, your outdoor siding or windows, doors, interior flooring, finished flooring, bathroom, covers it, and all for $10,000. So keep that in mind as we go along. Okay, there's something that I started thinking about since I started making this video, and that is I've discussed this being mounted to the ground via whatever caissons or bolting it to the concrete footing, but there's something I didn't think about that there could be some issues with the building department. They say, well, no, we can't let you build this, but if it were a trailer, then it might be more by in some areas. The building is sitting again on two great big 8x8 pressure treated beams that run parallel to each other, and then the building is connected to that. Those beams could be mounted to a trailer frame, a heavy duty trailer frame with wheels on it, which might be a little bizarre, but it would definitely supply the needs might supply the needs of the local building departments. But the issue would be that that trailer could blow over, the whole building could blow over in strong winds. So somehow that frame with the wheels on it the frame would have to be tied down somehow, which I have no idea how that would be done, but it's something to keep in mind, since there seems to be this ability for having tiny houses that are on trailer frames. So it's just something to think about, and I wanted to add that to the other bit about how the building goes up. Okay, you've got all your parts lined up for your building. You've got everything. You got all your ducts lined up. You're ready to go, but you don't have a place to construct this building. In the cities, there are thousands of little postage stamp lots that the owners have been sitting on forever, paying taxes and are not making any income off of. Find out where they are. Say things like lots in alleyways, backyards, industrial parks, near rail yards, near freeways. There's lots everywhere. So let's say you find one that you like, you go to the courthouse, find out who owns it, make them an offer. See if you can work out an agreement, like a 10-year lease agreement with the option to buy at the end. There's just endless options that you could work with people on. So anyway, that is the possibilities that you might think about. I realized that earlier I'd said that I wasn't going to be selling any parts or any plans, components for this building, but I've got to move this out of here. So I'm going to be selling it. We're going to dismantle it, and then if someone wants to purchase it, please contact me through my website. All right. Okay, here are the beams that go across. You can kind of see in here how they have these little metal tabs here that are part of this welded end that go onto the column, and those snap into position on the columns. And so I think that pretty much covers how the frame goes together. All right, here are these columns that I was talking about that are prefabricated. There's quite a few here stacked up next to each other. Two people can very easily take and move those and lift them up to make that assembly. I just wanted to show you that. Now I'm going to show you another part. Here you can see, this is just one unit. I thought I'd just give you a shot of the one unit put together. The two columns, which are prefabricated, and the beams that are put on. Again, everything just snaps together. The way it's attached at the base, each one of these, I don't know if you can see you can't see the detail in this photo, but basically there's welded pads at the base on all four of these legs in this one section, and those steel feet have 4 holes in them for screwing this system down to whatever substrate you're going to use. In this case, like I said, I use the 6x6s. Okay, now I'm going to go on to something else. Okay, here's the structure that I was talking about, the framework to the building. When this is snapped together, there's not a whole lot to do because it's all, if the base is level to each other, these two areas here, which I, in this case, used 6x6 pressure treated, then anchored those to the concrete. This is just a driveway. I'm not suggesting anyone should do that. I'm just saying that's what I did to secure the building, and it did sustain the 60-mile-an-hour winds. These sections here, you see the crisscross structure, those come pre-assembled. This section right here comes pre-assembled, and there are two parts, and then the other parts are the beams that go across. Those snap into these areas all the way wherever you want to place them height-wise. So those sections are bolted. Again, they're bolted side by side. I bolted carriage bolts with washers on the other side, and since there's holes everywhere, it's about every 12 inches, and put that whole assembly together. I think that kind of explains how that goes together. I'm going to show you some other things in a moment now. And here's a shot where here's the columns, and this is the beam. And you can see how they have these, you can't see it really well in here, but there's 3 pins on the other side of this welded collar here that snap into those slots. You can see the slots there lined up. And then this right here is like a safety lock that comes down and pins through the 2 pieces. So there's no chance of this hopping out given a situation like a seismic event. And here's a shot of those columns I was telling you about that have the welded pads on them. You can see they have places to bolt that down. This is kind of a cutaway of one and a cutaway of another one. I'm just kind of throwing this this photograph in here. This is what I consider really disgusting use of materials. Look at all the lumber in this. It's just obscene. That's all I can say about that. This is a shot of the beam, the orange beam that goes across from one side of the building to the other. There are 2 of those, of course, and wherever those are places where the floor or the ceiling or the roof would go. You'll note that there is a step that goes right here that's built into these steel beams, and they're hollow, of course. But I used they would normally use that to put some type of wood or some kind of system going from one side to the other to hold the goods in the racks in the stores that you would see. But in this case, I used 1/8 inch plywood that is tongue and groove plywood with a small spacer running the full length of it, glued and nailed to the bottom of this plywood, so that when the finished floor, when I put the finished floor in there, it would be even with the beam, so there'd be no lumps or anything that would cause it to be uneven. So anyway, I think that covers that portion. Oh, another thing though, what I wished I would have done is I wish I would have painted the underside of this plywood, because it's the ceiling on the first floor, and it would have been a lot easier to paint it then before I put it in. Okay, here's a drawing I did for my building. You can see where I took out the cross bracing in the areas for the windows. You can follow these lines here, kind of see, so it was just very simple to do. Again, the 4 bays, some on the right and left side of the building, where it sandwiches together with the 3/4 inch pieces of plywood and bolted every 12 inches. And the reason I'm showing this, because for my building, I found it to be very simple just to take and get these. This is a 2x6, and these are 2x4s all the way down. And it's just very simple to lay them up there and screw through the columns to hold them in place. And now you've got a place to sheathe the building on the outside, and also the same thing for the window frames. You can see this part here and here where you just basically take that window frame and just screw it to the face here. Okay, here's a drawing I did for the front of the building, which was the most complicated part. I struggled over this quite a while to get this organized where it worked for my building. The cross bracing and these beams are located the same on the second floor on this side of the building as they are on the other side, window as well. So you understand how that works. Again, the 2x4s are screwed to the outside of these beams to have a flat plane surface to screw the panels, the corrugated steel panels to. Now when you get down to these two storm doors on the front, I had to put the beam at the right height, as you can see here, for those doors to screw to the wood, and then I made a flashing that came off of this top portion. It came out. It sticks out quite a ways and extends out a bit to the right and left, sort of an overprotection for these doors. I didn't have to put any tape or caulking or anything on these edges because of this eyebrow, this overhang flashing, counter flashing, which I'll show you in a bit. I think that covers how the system works here. This is a drawing I did for my building, and as you can see here, here's your first floor and your second floor, and there's cross bracing here, and this cross bracing is to keep is to make a little bit better structure for this kind of movement in the building, say for winds or seismic conditions. Also, and those are just inexpensive metal straps, which I'll show you in a bit more detail. This right here, these extra beams that you're seeing here, I put those in for the purpose of having a place to connect window frames and siding issues. I think that covers it. So let's go on and I'll show you the details of those straps and how they're connected. Okay, here you see the steel diagonal strap that I was speaking of, and it's connected. It's just 1 1/4 inch by 1/8 inch, and then it's connected. It's just a hole drilled in the end of it, and a turnbuckle and a carriage bolt. Very simple. The other end, the steel strap has a hole in it, and it would just be attached the same way without the turnbuckle. You would just screw that hole straight to the side of this vertical column that has all these holes in it. So we're going to move on now to other things. Okay, here are the two columns here and here that I was talking about that you put and sandwich together with a piece of plywood, 3/4 inch plywood, and then bolted together those two sections with carriage bolts and tightened. I am going to show you in a second the side view around here, around the side, use my other hand here, around the side here where these two bolt through, so you can see how simple I did this. All right, now we're looking at the side view. This is the angle that we were looking at before, where the plywood is. Sorry this is such a mess. I had to paint this the color of the interior after I put it together. I should have done it before I put this together. Anyway, this is the steel column. This is inside that column. You can see this hollow area. It has stamped holes in it all the way up and down. That makes it real easy to put a carriage bolt, which is right here. So you just drill through your plywood to match the hole on the other side of the other column and throw a nut and washer on it and you're done. I was done. The thing I wanted to mention though was this piece of plywood, which is 3/4 thick, only goes up to the face here and just to the back of this, no further, because you don't want it to intrude into anywhere further past the outside of this column. I think that's it. We're going to go look at the windows here in a second, how they were mounted. Okay, we're going to talk about the windows, but before we do that, the windows and the window frame, I want to talk about this plywood that sandwiches between here, and it is 1.5 inches protrudes out from this flat surface here. On the other side of the flat surface, it's even with it, it's flush to it. Once these are installed, you can, I drilled holes for these dowels to go into. These dowels are basically used for joining wood for anybody that makes furniture or anything. You can buy them by the hundreds, they're very cheap. So the holes are drilled every 12 inches and they're used to support the finished panels. These finished panels are made of OSB. You've probably seen this stuff before. Very inexpensive. It does have some kind of good insulation qualities versus sheetrock, and it's a lot easier to deal with. They've been painted with an outside deck water-based paint, which is extremely durable because it's made for the deck, and you get it any color you want. And I rather like the texture of the OSB when it's been painted. It's not just slick, but it's got a little bit of texture to it on the not this side, but on this side. Anyway, you can see where when you put these in, then you just slide the pegs over like this, and they secure these finished panels onto all the walls. Not only, we'll go into later on what other things you can do with this than with these pegged holes, and I'll explain that to you in a bit. So the frame of this window is basically supported. So I basically made the wooden frame in a 2x material to fit this window, this Home Depot vinyl window, which is very good, very well priced, 36 by 36 window. The building has 2x4 belts around it, you might say. So I chose what I thought was the appropriate height and put these torques, these long wood screws that go from this side to the other, through the other side and then into the wood, holding it to the outside of this frame. In this case, this is just a piece that didn't need to go any further, so I stopped it there. And this one goes all the way around the building, and the one you can't see above does the same thing. So now that we have these, now that I have these set in the proper place, I just took this frame, pushed it up against these wood, and screwed it with these long torques that go all the way through this wood and into the 2x4s. So now the window frame is in. You go on the outside and take this vinyl pre-hung window, which has a flange on the end of it, push it against that 2x4 and just screwed it right onto it, and you've got a window that quick. Now I'm going to drop the camera down and show you something I did using, again, these columns. I love these columns. They have holes in them everywhere. You can screw things to them. They're amazing. Okay, so hold on. Okay, here's a shot of the second floor ceiling, which is the same as the first floor ceiling as far as this cross bracing goes. These cables, these diagonal cables that I'm pointing at right here and here. And I'm going to show you in a moment the detail of how they connect to each corner. Okay, here's a close shot of where those cables meet. And basically what you see here is just a U-bolt that's installed where these holes, which the holes are already there, of course, and then bolted from the backside, which are easy to get to, and then the cable's installed. And so just slipping this U-bolt on and putting it in and locking it down, that was it. Okay, here's some of the components I used to make that cross bracing assembly up. Turnbuckles, U-bolt, and some of these other, this part here is the loop, and then this right here just wedges, the cable goes through and comes back, and then it's a big crimping tool that I used, that I found at Home Depot again, and just a very simple system, and I got this done pretty quick. Okay, we're on the second floor now, and this is a shot to give you a perspective on where things are, where these brackets that hold the roof together on. So I'm just going to kind of swim around the room and show you where this is. So again, if you look here, there's a plywood separating the columns that are sandwiched together, and then up above you can see the two beams that hold the floor downstairs. They also hold the ceiling panels upstairs, and they have these bolts that go through. Those serve as a connecting point for the brackets that hold the roof beams up. So we're going to swing over here and see the same spot. I pulled some panels back so we can take a look at this, and as soon as I get on the ladder I'll show you. Okay, where we left off at that plate washer going through the beam and then up to this Simpson bracket, which is placed at the center of the roof, the highest point of the roof, which is 9.5 inches. I didn't want to exceed that because of buckling of the corrugation. You can see it repeats itself every time you get to another set of beams, the same system. And then as you go, as the roof goes closer to the edge, it gets a little lower, so you're using the same bracket, but it's cut down a little bit, a 2x4. And then at the edge, it's connected, the roofing screws into a 2x6, which is mounted on the outside, just like the other 2x4s that are mounted on the side to support the siding. So the siding and the roofing both screw to this same 2x6. Also, I wanted to mention that when thinking about this, if I were just designing this for myself for snow loads, I would have increased the number of brackets, say like one here, one there, as you go along, to handle the snow loads, if that were an issue. But this wasn't in this situation. So we're going to go back now, and I'm going to show you the brackets again, a side view. Okay, here's a cross-sectional shot of the two beams that go from one side of the room to the other. And here's that ledge again for the decking on the floor, which is also used again for the drop-in panels for the ceiling on the third floor. This is a Simpson HD3B hanger that I use in this project, and that I believe that this carriage bolt is a 1/2-inch carriage bolt, if I remember correctly. Now I'm going to go to another shot to show you more detail on this right in here. Okay, here's a closer shot of this cutaway. Here again is that large washer and a nut. I think it's a 1/2-inch carriage bolt. You'll notice that these two nuts here and here are oversized. They're bigger than this 1/2-inch shaft. The purpose for that was to keep this bolt centered so it didn't shift to one side or the other, or cause this washer to sling over to one side and not grab both beams at the same time. So that's just a nut that seemed to fit well between the two beams loosely over the shaft. Also, you'll notice that there's another nut that's same size as this one, which is a 1/2-inch nut that I put on there, and I screwed it all the way up just to hold this loose nut in position while I put the whole assembly together. So I think that covers that, and now we'll move on to some other parts. Okay, on the building I designed and built for myself, this is the cross beam right here at the end, at each end of the building. There's not two like there are in the midfield. There's only one beam on each end, and I designed a mock-up before I built it using these hangers and clamping them temporarily to the 2x at 9.5 inches from the top here to the top of this beam. So basically you just adjust it and put some screws in there because there's holes in these hangers. Now those are Simpson SBVs, which is what this is. And I drilled some holes into here and put some sheet metal, some heavy duty sheet metal screws to hold it to the beam. And as I got further towards the edge of the roof, where it's not as high from here to here. I used a shorter hanger called a CF, and that worked out good for me. I think that covers this part. There's something I forgot to mention about these pallet racks, these vertical portions of the pallet racks. There's a diagonal that runs. You can see where these diagonals run. There should have been one that went right through the window here, but instead I just basically sawed it off and swung it out of the way. There was no notable structural integrity lost by losing that one diagonal here and there for windows. So that made that very simple. Like I said, swung it out of the way and just left it inside the wall because you're not going to see it. Something else I wanted to mention, between the finished interior wall and the finished exterior siding, there's 5 inches of space for insulation. I would have used, if this would have been a building that I was going to finish, and it would stay here, I would have put fiberglass batting, in the bags, paper bags, the fiberglass insulation. That would have been perfect for this. But I wasn't going to do it because the building's going to be taken down and moved. Let's see if there's anything else here. I think that pretty much covers it. So we're going to go on to some other subject matter. Now here on the outside, you can see more detail of how I screwed these. You can see the flanges that are integral part of the prefabricated, pre-hung, I should say, pre-hung windows, those vinyl windows. So basically, you can see where maybe you can't see, but I don't know, I'm just gonna share this with you, but I just drilled some holes and screwed them right into the wood frame. On that other drawing, I didn't mention that I put some vertical pieces of 2x4 connected to the beams again, to the columns rather, as a place for the flange of the window to screw all the way around. You can see also how this window protrudes out from the finished siding, and I'm going to show you some detail on how I flashed these windows and made them watertight. Okay, this is a shot of the window here and the siding coming down to the top of that window. It's kind of a hard shot to understand perhaps, but this flashing goes towards the building at a slight angle so that it drains water off from the rain, and then it tucks up underneath about, you can see where the measurements are here. And I put some sealant on the corners because the water will naturally shed off this way, but if it gets into that corner, it can creep back into the building. So all I had to do was just squirt a little bit of caulking up in there. It's sort of a nasty little bit, but it works fine. And it could have been a different color, but that's just what I did. I had that around. This is called Ultra Bond, and I got this at Home Depot of all the places. Home Depot's just been great. They have so many things they have some pretty decent components to build a house with. And it sounds like such a hype for them, but it's not. Anyway, this material right here, I did a lot of homework, a lot of research on it. This is just amazing. It's UV resistant. It's waterproof, and when they say it sticks, it sticks. It does not leak. Matter of fact, I'm a little concerned about ever having to take this off because this building that is temporary building, this prototype building is going to have to be taken down eventually, and it's going to be a bit of an issue to pull this stuff off, I think. Okay, this is the most embarrassing part of the building, and it's because I tried so many different ways to create flashing for this window. None of it was simple or effective. This vinyl window sticks out a bit, as you can see, from the corrugation. And all I had to do was to wipe down the corrugation and the vinyl with some alcohol and let it dry. And I applied this tape. Now this is a close-up shot of this tape, so it looks really nasty. But when you stand back from the building a few feet, it really isn't. It just looks like a continuation of the window frame. But this material is just amazing, and I will show you that now. Here's the window here finished with the flashing at the top of the window and the sides and bottom with the Ultra Bond. You can see it doesn't really show up that much, the tape. Okay, here's a drawing I did for the front of the building, which was the most complicated part. I struggled over this quite a while to get this organized where it worked for my building. The cross bracing and these beams are located the same on the second floor on this side of the building as they are on the other side, window as well. So you understand how that works. Again, the 2x4s are screwed to the outside of these beams to have a flat plane surface to screw the panels, the corrugated steel panels to. Now when you get down to these two storm doors in the front, I had to put the beam at the right height, as you can see here, for those doors to screw to the wood, and then I made a flashing that came off of this top portion. It came out. It sticks out quite a ways and extends out a bit to the right and left. Sort of an overprotection for these doors. I didn't have to put any tape or caulking or anything on these edges because of this eyebrow, this overhang flashing, counter flashing, which I'll show you in a bit. I think that covers how the system works here. Okay, you can see the front of the building here. These are the two storm doors, and they were installed with that frame I was just talking to you about right behind here. This is where those 2x4s would be mounted, and that frame would screw underneath here to that. And then, as you can see, the counter flashing at the top is pretty simple. It tucks up underneath the corrugation, and let me see if I can get back a ways here, and you can see how the corrugation is one piece coming from here down to here. This tucks up underneath that corrugation, and it extends out a ways to the right and to the left so as not to cause any migration of water to go into the edge of the door. Also, it sticks out quite a ways from the building as well. You can see it here. This is probably a good 6 inches or so. And the eyebrow above that is made out of polycarbonate, a greenhouse material, siding for that. And I used conduit, electric conduit that was bent and then mounted to the side of the building and secure with these little straps that I found at a plumbing supply. So anyway, that's pretty much it. And then I'll show you a photograph of how I built the steps going up. Okay, here you can see the shot of a corner of the building right here. This is the corner, and this is a kind of a cutaway. Here's the flashing here, which would go full length of the building, but it's just kind of a cutaway. You can see where you drill and screw right into those strips of 2x4s I was telling you about. These screws are gasketed headed. You can drill them with a portable electric drill, and they seal right up against the metal. And so it's wherever you decide that, for me it was wherever I decided to put the 2x4s, that's where I just screwed it into. And on the flashing on the corners, this is a 5.5 by 5.5 flashing that has rolled edges on it, and that is just kind of pushed against the building, and I screwed them straight into the sheet metal. It was very simple, and there's no issues of caulking or anything because you have one or two of these corrugated ribs that any water migration that would get through the little edge here would just drain straight down and onto the ground. So that's not an issue. I think that covers it. Now these sheets, I just made them, I had them cut to length. Most companies will do that. They'll cut it right to length, whatever you want. And I had it in two segments, the first floor and the second floor, with about a, I don't know, about this much overlap, but a 4, 5 inch, 6 inch overlap, depending on what I felt like doing. So it's really simple to install this corrugation siding and roofing. It's the same principle. Okay, I'm going to discuss plumbing now. And here on the first floor of the kitchen, you can see the kitchen counter and the plumbing below the sink, which goes behind the refrigerator and dumps into or connects to this main wastewater pipe. Now this pipe will go all the way down through the floor and then exit whichever direction I wanted it to go. It could go straight down or left or right or whatever. So, because there's a nice crawl space under this floor, which makes it convenient to do the plumbing. Anyway, so in a moment, we're going to switch over and I'm going to show you, this is the more complicated part of the plumbing, and we'll talk about that now. Okay, looking at this plumbing, this is the only plumbing you see in the building that's exposed, and most plumbing like this is put into the walls, but being that we didn't want to make things complicated and later on would be a problem. If I had to do this in my building here, I would have had to run things, it would have been a spaghetti field, a nightmare of fittings. This is really simple, and architecturally I think it's okay. I got 3 fixtures that this system that you're looking at supports for its draining. And this one is the tub, the sink, and the toilet. And they all go again on this long 4-inch pipe that goes through the bottom of the floor all the way through the roof. And that vents as well as supplies an area for that wastewater to go down through the building and into the sewer line. So we're going to go upstairs now and take a look at the fixtures upstairs and how they connect to this. Okay, this is the back portion of the upstairs room. The bed's over there, there's shelves above the bed, the elevator, which I will show you later, shelves, window, etc. But this is probably consumes about a quarter of this room. Again, this is a $10,000 project. This was not, I couldn't just go spend money any way I wanted, but I was trying to go for some quality things that would last and survive. That was my mission for my project. This right here is a soft, UV resistant plastic horse trough, right? Now that may seem a little strange to you, but for the cost of it and the durability, we tested this outside to see what it felt like to get into this new horse trough, and it was really comfortable. I mean, the fact that it's somewhat pliable and deep, it was enjoyable. Then the other thing was to keep all the fixtures inexpensive. This is a restaurant faucet for big sinks, but I used it here because you could swing it over and use it for your lab or use it for your tub, and that worked out well. The toilet's just a low flow toilet. Then I don't think you can see this in the shot here, but this is a piece of electrical galvanized conduit that I bent and attached to the walls for this curtain, which gives you some privacy in the if you need it. Again, if most of the living is done downstairs, and basically this is a shower and sleeping area, or rather bathing and sleeping area, you could come up here by yourself and be in a very large bathroom, as far as that goes. Anyway, so that covers that, and I'm going to do a full shot of the whole building in a little bit, but I'm just kind of going through the details of this. You can see where the plumbing goes through the floor, where we discussed how I hooked up to the main stack. Now that main stack, I stopped here, again, because this is not hooked up to the sewer system, and I didn't want to waste the material at the time, but it would continue all the way up and then go out as a vent That's what's missing there. I think that covers this one segment, so we'll go on to other things. This is the kitchen counter. This is pretty much your kitchen right here. It's got lots of storage. This is a restaurant workstation that I got wholesale from a restaurant supply. It has adjustable legs on it to level it out, and it's a very heavy gauge stainless steel. I cut a hole in it and mounted a sink, and then attached the fixtures to it, the water fixtures. This has been a really good system for a kitchen. Easy to clean, it's got a nice backsplash on it. And then I'm going to talk about the flooring next. Okay, I'm going to show you the flooring. This stuff is great because it just snaps together and you're done. Again, Home Depot, I hate to keep hyping them, but they have a really good product here. I did a lot of testing with different flooring, and this was a little on the expensive side, but it was the most durable and the strongest as far as snapping together, putting it together, and taking it apart to reuse it if the building were ever taken down. Anyway, it's called Life Proof, and it is a vinyl material. It's got several layers in it, one of which is soundproofing, which I really liked, and it's a real tight fit. You can't really tell the difference from this and the real thing. I mean, this photograph probably won't do it justice, but it looks real. So in a minute I'll show you how it snaps together. Okay, it's this simple. Basically, these stagger, each row will stagger, but for the time being, I'm just going to put the two of them together, and it just is this simple. You tilt the board like this, push it in there, and that's it. It's done. And it's a floating floor, which I really like a lot too. So any expansion or contraction doesn't matter with it. It always stays flush to the subfloor. I did want to mention that I had several times had to deal with the height of the decking that fits into the beams. It has to be really level to those beams. So whatever strip I had to make to raise the 1 1/8" plywood up to the level of the steel beam was critical. So anyway, that's about the floor. Okay, I'm going to briefly talk about lighting in the building, and we're going to go in and I'll show you what I did for what it's worth. This basically is polycarbonate tubing that I got that actually is in 2 strips and is coupled together, and I put some LED strips going through it. They're back to back, and the amount of energy that it takes to run this is just really minimal. I did the same thing upstairs. As a matter of fact, I'll take a little trip on this elevator here. We're going to go up and take a look at how that was done as well. Okay, I'm going to turn this on here. This is a $11 piece right here. This little controller, couldn't believe how cheap it was. But that's, here I'll turn it on and off. But that I just tucked in the corners with, again, some polycarbonate tubing, and just used that to illuminate the room, which has worked just fine. The way this space is laid out right now, it works really well. You have your long kitchen counter to work off for food and storage against the walls, refrigerator, kitchen table, couch, television set. This is the first floor. This is where most of the time it's going to be spent. Upstairs would be for sleeping, or going to the bathroom, or bathing. So, like I said, most of the time it's spent down here. That's why you want to keep this as open as possible, with a good, well-lit area. The hardest and most difficult part of the project was designing something that would make it easy to go from first floor to second floor. I like machines a lot, so I designed this elevator here to do that job. It took up the minimum amount of space. It was in the corner, it's like 36 by 36 or something, and that worked well. But I'm not going to show you anything about how I built that. The other choice would have been a ladder, a slightly tilted ladder, maybe came out to about here, with handrails, so you would go up and then exit to the left. That would be the choice that, and it would be that's even less money than the $10,000 to build this building. That's that. You can see how it works, so I'll share that with you. It works quite well, and it's pretty strong. But okay, I'm going to kind of backtrack on these beams here that go across that support the floor. The floor decking again comes off, floats on here. This is a cross section of those beams. The reason I mentioned that there has to be some support in the middle of the beam span is because when walking, putting the pressure of 1 foot here and then stepping over to this side may cause a slight amount of flexing. Now, I don't know if that was a real issue with the flooring staying so that it would flex together or not, but I did put a bolt with a welded washer on it and clamped it to the two halves in the middle, again, in the middle of the span to keep that from happening. The disadvantage of this is that this space from the top of this carriage bolt, which is welded to the washer, is probably about 1/4 inch, and that's going to be sticking up on the floor. So when you go to put your flooring on there, you've got that issue to deal with. So I haven't quite worked that out, but I just welded and ground that off and then dealt with it by other means. So I think that if somebody is smart enough, they'd figure out a way to cause, either put some wood here and bolt through it. Somebody's going to have to come up with a better idea than what I have here. So that's just one thing I never really resolved. But I think it has a possibility of being an issue, again, like I said, of the floor flexing. It's not a structural issue because these beams can hold a lot of weight. But it's just the slightest amount of, like I said, of flexing, opposing each other might cause the flooring to do something strange. So anyway, in passing. Okay, there's something that I started thinking about since I started making this video, and that is I've discussed this being mounted to the ground via whatever caissons or bolting it to a concrete footing, but there's something I didn't think about that there could be some issues with the building department. They say, well, no, we can't let you build this, but if it were a trailer, then it might be more permissible in some areas. The building is sitting, again, on two great big 8x8 pressure treated beams that run parallel to each other, and then the building is connected to that. Those beams could be mounted to a trailer frame, a heavy duty trailer frame with wheels on it, which might be a little bizarre, but it would definitely supply the needs might supply the needs of the local building departments. But the issue would be that that trailer could blow over, the whole building could blow over in strong winds. So somehow that frame with the wheels on it the frame would have to be tied down somehow, which I have no idea how that would be done, but it's something to keep in mind, since there seems to be this ability for having tiny houses that are on trailer frames. So it's just something to think about, and I wanted to add that to the other bit about how the building goes up.